In the frozen silence of deep space, a traveler from another star system began to stir. Astronomers called it 3I Atlas, a comet that should have been dead, silent, and cold. But something impossible happened. It heated without sunlight. It pulsed like a heartbeat. It emitted radio frequencies that seemed aware. Each time we observed it, it changed, as if it knew we were watching. Nickel without iron, shockwaves in the void. A hidden heat source that refused to die. And then a signal whispered across the solar wind, locked to the frequency of hydrogen. Our universal calling card. What awoke 3I Atlas? Was it chemistry, physics, or something waiting to be seen? Tonight, we follow the evidence, the data anomalies, the living comet hypothesis, and the eerie possibility that the universe itself might be watching back. This is the story of the comet that switched itself on. For months, it drifted in silence, an anonymous wanderer moving through a region of space so cold, sunlight was little more than a whisper. By all laws of physics, 3I Atlas should have been asleep, frozen solid, locked in eternal stillness. Yet one evening, telescopes across the world picked up something no one expected, a sudden flare, a surge of light from a comet far too distant from the sun to glow. It was faint at first, a subtle pulse against the darkness, but then came another and another, as though something inside had stirred. Astronomers stared at the data in disbelief. This wasn't normal. Comets wake up when they approach the sun, when heat cracks their icy crusts and drives out plumes of gas and dust. But 3I Atlas was still billions of kilometers from that threshold, too cold for any known reaction to occur. It was behaving as if the rules had changed. At first, teams at the European Southern Observatory and NASA's Infrared Telescope facility assumed a calibration error. Maybe a glitch in the sensors, maybe a cosmic ray hit the detector. But then independent amateur astronomers confirmed the rise in brightness, real, measurable, and increasing. Within 48 hours, spectral readings showed a mixture of water vapor and cyanide compounds, as though the comet had begun breathing into space. That was impossible. The object, designated the third confirmed interstellar visitor after Oumuamua and Borisov, had been catalogued as inert, a lifeless remnant from another star system. Yet this surge, this switching on, defied that. Some called it a chemical bloom, others a surface venting. A few dared to suggest something stranger, an internal mechanism awakening after a long dormancy. But what mechanism could exist inside a rock and ice conglomerate drifting between the stars? As images began streaming in from Earth-based observatories, something unusual stood out. The coma, the glowing cloud around the nucleus, was not uniform. It pulsed in intervals. Every few hours, faint jets of material burst outward, then faded, repeating in rhythm. Not chaotic, not random, rhythmic, almost like a heartbeat echoing through vacuum. Spectrographs revealed further oddities. The gases released weren't what scientists expected from typical cometary activity. Instead of carbon monoxide or simple water ice, the signature was rich in nickel, yet missing the iron that should accompany it. That detail sent laboratories scrambling. Nickel without iron was chemically asymmetric, a ratio that didn't exist in nature on this scale. On Earth, such purity was only seen in engineered alloys refined intentionally. Still, mainstream astrophysics urged caution. Coincidence, they said. A rare but natural mineral composition. Yet for a comet that had journeyed between stars, formed in another system entirely, the odds of such selective chemistry were astronomical. Then something even stranger happened. As the comet brightened, radio telescopes detected faint oscillations, bursts of frequency coinciding with its visual flares. Not a signal, at least not in the communicative sense, but structured enough to raise eyebrows. The frequencies repeated in harmonic intervals, matching patterns sometimes seen in plasma discharges or artificial systems under stress. When data from the Allen telescope array leaked through independent channels, a small uproar followed. The burst didn't align with known background noise. They appeared timed, intentional even. But official commentary was almost non-existent. NASA's Jet Propulsion Laboratory dismissed it as instrumental interference, while ESA quietly removed a mention of the anomaly from their observation log. The story could have ended there, filed away as another deep space curiosity, but the timing made it impossible to ignore. 3I Atlas's awakening happened just as Earth's magnetosphere registered a subtle resonance spike, a fluctuation often triggered by solar events. But there was no solar event. No coronal mass ejection, no storm, no burst. The spike had no known cause. Could it be coincidence? Or could the interstellar object have interacted with the Sun's outer field somehow, miles from where that influence should even reach? Researchers in Finland later noted that a similar pattern appeared days before the comet's first outburst, a geomagnetic ripple with a faint signature matching the object's position in heliocentric coordinates. That led to one hypothesis, far-fetched but fascinating. Perhaps 3I Atlas had passed through a region of charged plasma or magnetic flux from the interstellar medium, a current that effectively woke it. If that were true, it meant deep space wasn't the silent void we imagine. It was active, volatile, and capable of flipping a switch on dormant matter. But others weren't convinced. A small group of astrochemists at Kyoto University proposed something else, an internal heat trigger. They theorized that 3I Atlas could contain isotopes unstable enough to decay slowly over eons, producing pockets of energy trapped beneath its crust. If those isotopes crossed a threshold even slightly, they might have caused a chain reaction, melting subsurface ice and releasing the gases that made it glow. The problem? None of the detected emissions matched radioactive decay models. No trace elements of thorium, uranium, or cesium. Nothing to explain a heat source powerful enough to reignite a frozen core. By this point, the comet's light curve had become unpredictable. It would brighten, plateau, then dim sharply before pulsing again, almost like breathing cycles. Each pulse was accompanied by a thin stream of green, ionized gas, visible in long exposure photographs as an emerald thread slicing across the stars. The color baffled experts. It suggested diatomic carbon reacting with sunlight, but there wasn't enough sunlight out there to cause that glow. And yet there it was. As weeks passed, conspiracy channels and even a few credible astronomers began calling it the comet that woke itself. Was it self-regulating? Could it possess an internal feedback loop, an unknown thermochemical mechanism that responded to environmental change? Theories multiplied. Some speculated that 3I Atlas might not be a simple comet at all, but a fragment of something larger, perhaps a broken shard from an artificial construct long disintegrated in another system. Others invoked the possibility of exotic ice chemistry, compounds of ammonia and methane that could react under quantum tunneling, creating miniature bursts of energy. No explanation fit all the data. The water vapor, the nickel asymmetry, the rhythmic brightening, it was too much for coincidence. Too organized for randomness. What unsettled observers most wasn't just the behavior, but the feeling that it was responding to something. Its activity increased when exposed to specific wavelengths of solar wind, as if it preferred certain frequencies. When a mild solar flare reached its region weeks later, it dimmed entirely as though recoiling, before reactivating days afterward. It was acting less like an object, and more like a system, something that sensed and adapted. That's when a fringe theory emerged, whispered first in private observatory groups before spreading online. What if interstellar objects like 3I Atlas aren't just debris from alien worlds, but messengers of cosmic chemistry, seeds or probes designed to awaken under the right conditions? The idea bordered on science fiction, Yet it wasn't without precedent. Scientists had long speculated that panspermia, the seeding of life between worlds, could occur via comets carrying organic compounds. But this was different. This wasn't organic matter merely surviving, it was behavior that implied intent. Of course, most mainstream researchers avoided the word alive. They preferred phrases like reactive mechanism or phase anomaly. But behind closed doors, several teams began quietly studying the pulse intervals and brightness ratios as though decoding a system log. They found that each flare emitted light at slightly shifted frequencies, like spectral lines sliding through a patterned cycle. Coincidence? Possibly, yet the pattern was clean. Too clean. By now, what began as a cold fragment of rock had become one of the most debated mysteries in modern astronomy. A body that should have been dark and dead was instead shedding light, breathing gas, and pulsing with precision. It had no engine, no power source, and yet it moved with purpose through the emptiness between worlds. Even stranger, its activity plateaued precisely when it crossed the Sun's magnetic neutral line, an invisible boundary dividing north and south magnetic polarity. Observers noted that as it entered this zone, the rhythmic outgassing stopped abruptly. Silence again, almost as if something had completed its cycle. And so, 3I Atlas continued its journey, fading once more into the cold dark. But the question remained, what caused that impossible flare? Was it natural chemistry or something designed to react, to wake up when conditions were just right? Because if something in deep space can turn itself on, what else out there might be waiting for the same signal? The first alert came from a small observatory in northern Chile, a faint but measurable surge in visible magnitude from an object that should have been invisible against the black. At first, it was dismissed as a data artifact, the kind of noise that plagues long exposures taken in thin, dry air. But then, within hours, other stations began reporting the same thing. 3I Atlas was brightening. Not gradually, but in pulses. When the reports converged, it became undeniable. Something had changed. The comet wasn't just reflecting more sunlight. It was emitting a glow radiating from within. That single discrepancy, the way light behaved around it, would become one of the most hotly debated anomalies in modern astronomy. For a comet drifting billions of kilometers from any significant heat source, such a flare made no sense. There was no nearby star, no passing shockwave, no gravitational tug capable of heating it. Even cosmic rays, the ever-present drizzle of high-energy particles, couldn't account for the scale or pattern of its awakening. Yet instruments recorded it clearly, a rise in optical brightness followed by an ultraviolet echo, the spectral equivalent of a heartbeat. The timestamp of that first flare, 0311 UTC, February 8th, would be pored over by teams across continents. Some noted that, oddly, the event coincided with a faint but global magnetospheric ripple detected on Earth. A fluctuation so small it barely registered, yet synchronized to the minute. It could be coincidence, but coincidences have a strange way of multiplying when it comes to 3I Atlas. Within the following day, data from infrared telescopes confirmed gas emission, carbon compounds, cyanides, and traces of water vapor. The problem was, by every known standard model, 3I Atlas was too far from the Sun to sublimate ice. It wasn't supposed to be outgassing at all. The math didn't fit, the physics didn't fit, and the temperature didn't fit. That's when the term switching on entered the discussion. It started as an offhand remark in an internal memo between researchers at the Max Planck Institute. If this data is real, it's as though the object simply switched itself on. The phrase leaked online through a translated forum, and within hours, the world had its mystery headline. But the deeper scientists dug, the stranger it became. Spectral analysis showed the first surge wasn't random, it followed a curve that resembled a controlled energy release. The light intensity ramped up smoothly, then dropped off in a near-perfect exponential decay. Not jagged, not chaotic, structured. It looked eerily like a signal curve, a system initializing, stabilizing, and then idling. Some theorists suggested chemical explanations. Maybe 3I Atlas harbored volatile ices trapped under dust layers, and a sudden micro-impactor cracked it open. But there were no known collisions, and the timing of the emissions, repeating in periodic bursts, didn't match a single event. It looked recursive, self-sustaining. The object's coma also displayed something new. An asymmetric jet tilted relative to its axis of rotation. That angle shouldn't exist unless the ejection was directional, driven by a focused process, not random venting. Even weirder, the jet produced photons polarized in a narrow band, suggesting a magnetic field alignment, something rare for a body of this size. For a while, the scientific community was caught between disbelief and obsession. The comet's behavior contradicted established models, yet the data was too clean to dismiss. Papers began circulating in private academic servers, each proposing a different mechanism: electrochemical discharge, piezoelectric reaction, even quantum tunneling of volatile molecules under extreme cold. But one dataset changed everything: the radio logs. A week after the initial awakening, an amateur radio observatory in Argentina detected a faint, repeating oscillation in the 20 MHz range, right as the comet's next brightening phase began. The oscillation wasn't noise. It carried a harmonic structure, rising and falling at consistent intervals. When researchers cross-referenced it with optical data, they found a near-perfect match. Every spike in radio frequency aligned with a pulse of light from the comet. That discovery raised a terrifyingly simple question. Was 3I Atlas responding to something or generating its own energy signature? NASA's Deep Space Network later admitted to detecting low-level electromagnetic activity in the same window, but labeled it non-causal correlation. Yet privately, some engineers noted that the signal pattern resembled plasma resonance, a phenomenon seen when charged material interacts with magnetic fields in a structured, oscillating way. Still, there was no external magnetic source nearby strong enough to cause that behavior, which meant the field had to be internal. In other words, 3I Atlas might have a magnetic heartbeat. The implications were staggering. A comet generating its own electromagnetic field meant internal movement, currents, charge differentials, maybe even conductive materials arranged in a way that allowed feedback. It wasn't alive necessarily, but it was active, dynamic, a machine without purpose, or one we simply didn't understand. By then, data scientists began mining historical telemetry from the previous months, searching for precursor signals. They found them, tiny flickers buried in noise, dated weeks before the full awakening. Weak, repetitive bursts of radiation, almost like trial runs. It was as if the object had been testing itself before the final ignition. More anomalies followed. When the Hubble Space Telescope trained its lens on 3I Atlas, analysts noticed the coma wasn't expanding outward evenly. It spiraled subtly but clearly, forming a helix pattern in time-lapse imaging. That geometry hinted at rotation synchronized with pulsed emission, as if the object was venting gas in controlled intervals, not constant release. That single frame of reference, pulses instead of streams, made the scientific community uneasy. It implied intentional rhythm, something cycling in timed intervals rather than natural. Chaotic outflow? Then came the energy discrepancy. Using multispectral data, astronomers calculated the total energy required to sustain the flare pattern. It exceeded what solar radiation could possibly supply at that distance by several magnitudes. The only logical conclusion was an internal energy reserve, but no known isotope decay or chemical reaction matched the signature. It wasn't heat, it was luminescence, driven by ionization far stronger than any passive process. So where was the energy coming from? Some whispered about alien technology, but others took a quieter, more haunting approach. Maybe this was an unknown cosmic chemistry, a natural but unclassified phenomenon, matter reacting to deep interstellar plasma currents like neurons to a pulse. A kind of cosmic biochemistry where energy isn't generated, but triggered. The phrase that started circulating among observers was resonant ignition. In this theory, 3I Atlas wasn't producing its own energy. It was reacting to invisible electromagnetic tides sweeping through interstellar space. In essence, it woke up because space itself passed a frequency that resonated with its molecular structure, like a tuning fork struck by the right note. If true, that would redefine what inert means in the universe. Objects might not be dead, they might simply be waiting for the right song. But speculation is a dangerous currency in science. NASA released a muted update. Comet 3I Atlas exhibits uncharacteristic activity at a greater heliocentric distance than expected. Investigation ongoing. No theories. No admissions. Just the bare facts. Still, the leaks continued. Internal emails referenced data stabilization issues and nonlinear feedback artifacts. Translation: something in the data kept changing in ways the models couldn't predict. Observatories would detect a flare, recalibrate their instruments, and then see the flare shift in wavelength, as though the object had heard the measurement and adapted. The idea of a reactive comet, one that adjusted to observation, was almost heretical. But even hardened skeptics admitted the numbers were unnerving. Each recorded flare was slightly dimmer when captured by more instruments. The more it was observed, the quieter it became. Coincidence? Maybe. But it mirrored behavior seen in self-regulating systems, ones that stabilize under external pressure. That led to another chilling idea whispered in closed forums. What if 3I Atlas isn't just reacting to cosmic fields, but to us? Of course, there's no proof, only data that behaves as though it's aware of being measured. Yet the psychological impact on the astronomy community was profound. Suddenly, the cold logic of orbital mechanics felt inadequate. Here was an object that refused to obey the script of physics, that flickered like a warning beacon across the dark between stars. Months later, when 3I Atlas crossed into a denser region of solar wind, its brightness stabilized for the first time. No pulses, no flickers, just a steady glow. Some said it finally found equilibrium, its internal forces balanced. Others believed it had gone dormant again, returning to its original silence now that its purpose, whatever it was, had been fulfilled. But one detail remained unexplainable. The initial timestamp, 3:11 UTC, February 8th, a precise moment when an object billions of kilometers away came alive, and the data surrounding it refused to conform to probability. It was as if an unseen hand had flipped a switch, not in our instruments, but in the fabric of the comet itself. The awakening of 3I Atlas didn't just challenge astronomy, it forced a deeper question. If matter can respond to invisible frequencies, if a frozen object can flare into life without cause, then what else in our universe is listening, waiting for the right vibration to call it awake? It began as a footnote, an odd line in a spectrum analysis from a deep space telescope in Hawaii. The chemical fingerprint of 3I Atlas showed a sharp emission peak at wavelengths corresponding to nickel atoms. That wasn't unusual. Nickel is found in many comets, usually locked together with iron, the two metals forming in tandem within the hearts of ancient stars. But here's the problem, the iron line was missing. At first, nobody noticed. In the rush to confirm the object's unexpected outgassing and bizarre switching on, the details of its composition were easy to overlook. But a young astrophysicist reviewing the data for calibration drift spotted the discrepancy. She double-checked the readings. Then again, The nickel signal was unmistakable, strong, pure, consistent, and the iron, which should have been there in nearly equal strength, was simply gone. When she sent the report upstream, the response from her supervisor was hesitant. That can't be right. Check the instrument's thermal baseline, but the baseline was perfect. So they ran the data through a second observatory and then a third. Same result. Nickel, without iron. That single anomaly rippled outward like shockwaves through the astrophysics community. Every known model of stellar formation, every theory of cometary composition depends on the coupling of nickel and iron. These two metals condense together in supernova ejecta. You can't have one without the other. It's as if you found pure gold veins in a world where gold never formed alone. Yet 3I Atlas had broken that law. The media never caught the nuance. It wasn't flashy enough for headlines. But behind closed doors, the conversations were different. Scientists whispered about the implications. Either the comet formed in a star system with impossible chemistry, or something had selectively removed iron from its structure. That second possibility was unthinkable. It implied processing, refinement, intent. When the European Southern Observatory ran follow-up scans using their high-resolution spectrograph, the data only deepened the puzzle. The nickel line was not only dominant, it was unusually pure, with line widths suggesting uniform atomic states. Natural objects don't do that. Thermal fluctuations, radiation exposure, collisions, all of these broaden emission lines. Yet, 3I Atlas's signal looked almost engineered, as though its nickel were forged under controlled conditions and then shielded for eons. One researcher compared the signature to a perfectly tempered alloy that's been frozen in time. Another called it an impossible isotope fingerprint. Soon, discussions shifted from chemistry to physics. Could the iron have sublimated faster? Could it be hidden deeper inside the nucleus? But spectral analysis can see through the coma, through the gas cloud, and into the heart of the object. The iron simply wasn't there. That's when someone proposed a daring explanation. What if 3I Atlas didn't lose its iron? It never had any to begin with. This would mean it originated not from a typical stellar nursery, but from an entirely different kind of environment, perhaps around a star with an anomalous nucleosynthetic history, or even a region of space affected by extreme magnetic segregation during formation. Yet no known star system, living or dead, has ever produced matter with that kind of ratio. Not one, so where did it come from? A few astronomers turned to laboratory data from particle accelerators. In 2023, experiments with high-energy plasma fields produced strange separation effects, nickel atoms clustering while iron dispersed when exposed to directed electromagnetic fields. It was a curiosity of condensed matter physics, nothing more. But when they looked at 3I Atlas's emission patterns, the parallels were hauntingly familiar. Could an interstellar object have formed in a region saturated with magnetic flux, strong enough to separate atomic species? Or worse, could it have passed through something artificial that altered its structure, like a manufacturing field frozen in space? Officially, no agency wanted to touch that theory. NASA's compositional report merely stated, observed metallic abundances diverge from standard chondritic ratios. Further investigation warranted. ESA didn't even issue a public note. But independent researchers weren't so restrained. A physicist in Prague released a paper suggesting 3I Atlas's metallic pattern resembled electro-refined alloys used in industrial processes, nickel-rich composites that resist corrosion and radiation. His conclusion was cautious. While no direct evidence of artificiality can be inferred, the observed purity exceeds natural astrophysical variance by several orders of magnitude. That phrase, exceeds natural variance, became a quiet lightning bolt in scientific circles. Then came the isotope readings. When 3I Atlas's reflected light was broken down at higher resolution, analysts detected subtle deviations in isotope ratios. Specifically, nickel-58 was overrepresented relative to nickel-60 on Earth. That ratio is stable, fixed by stellar fusion processes. But here, it was skewed, suggesting fractionation under conditions that simply don't occur in nature. The only places scientists had ever seen such isotopic distortions were inside nuclear reactors or in the remnants of meteoroids altered by particle bombardment in high-energy environments. But this wasn't a fragment, it was a whole comet. So what could have reshaped its atomic structure on that scale? Some pointed to cosmic radiation over millions of years, but that would have affected iron too. Others suggested it passed near a magnetar, a type of neutron star with magnetic fields trillions of times stronger than Earth's. In such a field, atoms could separate by mass, potentially stripping away lighter elements or altering isotopic ratios. The problem? There are no known magnetars near the comet's trajectory, none close enough to account for the precision of the pattern. And then another anomaly surfaced. During its period of peak activity, when 3I Atlas switched on, instruments detected faint ultraviolet emissions consistent with ionized nickel vapor. That meant the nickel wasn't just embedded, it was moving, releasing into space as though activated. But nickel requires immense heat to vaporize, temperatures reaching thousands of degrees. At that distance from the sun, there was no source for that kind of thermal excitation. Unless the excitation wasn't thermal. Plasma physicists began theorizing about electrical interactions. If 3I Atlas were conducting current internally, electrostatic discharges might ionize surface metals selectively. And nickel, being highly conductive, could act as a medium for those discharges. That would explain why nickel flared while iron, if absent, remained silent. It was as though the object's outer shell was designed to respond electrically, to light up under the right frequency, while everything else stayed inert. The term reactive shell appeared in a handful of private research notes before vanishing from official communications. Still, it lingered among those following the mystery. Could 3I Atlas be wrapped in a metallic lattice, natural or not, that allowed energy to propagate across its surface? That would make it less a comet and more a conductor, a vessel. One astrophysicist, speaking anonymously, likened it to a cryogenic capacitor adrift between stars, a structure that stores and releases charge when encountering solar wind or interstellar plasma. In his words, if such an object exists, it's not just chemistry, it's circuitry. By mid-year, data models were rewritten again. Scientists realized that 3I Atlas's nickel glow fluctuated with solar flux levels, even from vast distances. Every minor increase in background radiation correlated with microscopic shifts in spectral intensity, as though the metal were tuned to the sun's frequency. It was reacting selectively, like a sensor waking to faint whispers of light. Still, skeptics argued that the conclusions were premature. Maybe the data was contaminated. Maybe background interference exaggerated the signal. But independent observatories kept confirming the same pattern. Every data set agreed, nickel strong, iron gone. The ratio wasn't noise, it was identity. By now, the comet had earned a new nickname among researchers, the alloy from nowhere. Even more intriguing was what happened next. When the comet's activity declined, so did its nickel emissions. The glow faded gradually, not abruptly as though the object were powering down. Yet, when it reactivated weeks later, the same isotopic pattern returned, unchanged, pristine, repeating like a coded signature. It was behaving less like a geological formation and more like a system rebooting under a set of conditions. And then came the final twist. Data from a spectral instrument in Japan picked up an echo, faint, reflective peaks matching the nickel frequency, bouncing off surrounding space dust. That shouldn't happen naturally. Dust scatters light. It doesn't reflect it in coherence. The only explanation was that the nickel radiation was coherent, meaning it was emitting in phase like a laser. The universe had never shown that before, not from a comet, not from any natural body. Coherent emission requires synchronization, coordination at the atomic level. the kind of alignment that implies structure. It was as if 3i Atlas wasn't just glowing, it was communicating. No agency dared say it out loud. Official channels went silent. But the independent research logs spoke for themselves. Nickel pure, iron absent, emissions synchronized, energy structured. It was either a phenomenon we've never seen before or evidence of something older than civilization, traveling between stars, still carrying the memory of its maker. Because if nature didn't separate the nickel from the iron, then someone or something once did. The more scientists examined 3i Atlas, the more it seemed to mock everything they thought they knew about thermodynamics. A frozen body hurtling through the deep void beyond Mars was somehow producing enough energy to vaporize water ice and ignite glowing jets of gas. The problem was simple but devastating. There was no sun close enough, no solar flux strong enough, and no friction or tidal force measurable enough to explain it. And yet, 3i Atlas was warm. Infrared readings taken days after its switching on showed localized heat signatures rippling across its surface, fluctuating in real time. Some patches registered above 230 Kelvin, nearly double what the solar environment at that distance could sustain. The data implied an internal process, something self-heating, pulsing with energy from within. It was as if the comet were burning a fire no one could see. At first, observers assumed instrumentation drift. Calibration errors are common in thermal imaging, especially at interstellar distances. But when 3 separate observatories, Chile, Japan, and Arizona, reported the same pattern at the same time, the error argument collapsed. The readings were real. That left only one question: what was producing the heat? The most conservative answer came from the European Space Agency: radioactive decay. If 3i Atlas carried trace amounts of isotopes like aluminum-26 or potassium-40, those could slowly release energy as they decayed. This mechanism explains some comets' internal warming in the early solar system. But decay follows a predictable linear path, steady, not rhythmic. 3i Atlas wasn't steady. Its temperature pulsed, rose and fell, sometimes dramatically, like breath drawn through invisible lungs. One astrophysicist at Kyoto called it thermal respiration. The term caught on because it fit the data perfectly. Every outgassing event followed a distinct temperature surge, followed by a cool down, and then another surge, regular, almost clock-like. But it was too deliberate, too cyclical to be decay. Something was modulating the heat from inside. That's when a second, more daring theory emerged: piezoelectric heating. The idea came from seismologists, not astronomers. Under extreme stress, certain crystalline materials, quartz for example, generate electric charge. On Earth, these discharges can even precede earthquakes, producing brief electromagnetic bursts. If 3i Atlas were composed partly of crystalline ice or silicates, and if internal pressure fluctuated as it rotated, maybe those stresses produced microcurrents. Those currents could, in turn, heat localized areas through resistance. It was an elegant solution, but it didn't fit either. The power levels implied by the data were far too high, millions of times greater than any known piezoelectric event. The energy output wasn't geological, it was industrial. Then came the shocker. Infrared instruments recorded an anomaly in phase with the object's rotation, a hot zone that migrated systematically along its equator. Not random, not chaotic, a belt of warmth that circled the body with perfect precision. The rotation period of the comet was about 9.3 hours, and the heat band moved with it, as though tracing an internal mechanism spinning beneath the surface. The implication was unthinkable. 3i Atlas wasn't just heating, it was circulating heat. No one said the word engine, but everyone thought it. In private, some researchers speculated that the object could contain metallic inclusions that conducted current, perhaps remnants of a magnetic core or an ancient fusion reaction long extinguished. Others wondered whether the comet had once passed through a region of space so dense with plasma that it absorbed charge like a capacitor, still releasing it slowly centuries later. If that were true, it could explain the pulsations, discharge, recovery, discharge again, but even that hypothesis couldn't explain how the heat appeared precisely timed to the emission of cyanide gases and nickel vapor. These processes seemed linked, as though the internal warmth was activating chemical reactions, not randomly, but sequentially. The heat was triggering chemistry. The chemistry, in turn, was producing light. It was almost mechanical. Then came the data leak. An anonymous astronomer from an unnamed agency released temperature gradient maps showing that the comet's interior, at least the portion detectable through infrared backscatter, contained structured layering, not homogeneous like natural rock, but stratified like alternating shells. Each layer emitted slightly different wavelengths, suggesting varying materials or densities. Some zones even appeared insulated, radiating less heat than their surroundings. If verified, this would mean that 3I Atlas had internal compartments. The scientific world erupted. If the stratification was natural, it could be a frozen core surrounded by carbonaceous deposits. But if it wasn't, if those shells were engineered, it implied the unthinkable. That 3I Atlas wasn't a comet at all, but a vessel of some kind. NASA, under pressure, released a short clarification. Thermal banding is consistent with compositional heterogeneity, not artificial structure. The statement calmed the public, but did little for the experts. Quietly, data analysts noticed that NASA's released graphs were truncated, omitting the highest temperature readings entirely. Why censor heat data? A few brave researchers pushed further. They noticed something else. The temperature peaks corresponded closely to bursts of low-frequency radio noise recorded by the Allen telescope array. The heat and the signal rose and fell together. The connection was undeniable. This introduced a new possibility: electromagnetic induction. If 3I Atlas were metallic, or at least partially conductive, it could generate current as it moved through the sun's magnetic field like a giant dynamo. The motion would create eddy currents inside its structure, converting kinetic energy into heat. In that case, the object wasn't alive. It was reacting to its environment exactly like an electric generator. That would also explain the rhythmic nature of the heat. As it spun, each rotation exposed it to changing magnetic flux, pulsing the current. But even this elegant theory hit a wall. The magnitude of the heating far exceeded what induction could produce at that distance. It was orders of magnitude too strong. Something was amplifying the current, or storing it. In other words, 3I Atlas wasn't just a passive conductor. It was behaving like a resonant circuit. Imagine a cosmic tuning fork vibrating to the hidden hum of space, absorbing and re-emitting energy across magnetic lines no one else could see. If so, the object could wake up only when the surrounding plasma density reached a precise threshold, the same condition that triggered its mysterious brightening event. That made scientists wonder, what if this wasn't an accident? What if 3I Atlas was built or born to awaken under those conditions? By mid-year, speculative papers flooded preprint servers. Some drew comparisons to thermogenic microbes, which generate internal heat to survive freezing environments. Others leaned into astroengineering, comparing the phenomenon to ancient satellites or probes designed to harvest energy from stellar fields. One even suggested that the object could be part of a dormant network of interstellar monitors, self-regulating nodes that awaken when nearing magnetic boundaries between stars. The mainstream dismissed it all, of course, but the timing was eerie. Just as the comet's internal heat reached peak emission, the sun released a weak coronal wave. Though not powerful enough to disturb Earth, instruments detected faint resonance between the wave and the comet's signal. It was as if the two were locked in conversation, each pulse from the Sun mirrored by a thermal heartbeat from 3I Atlas seconds later. Coincidence? Or synchronization? The possibility sent chills through the astronomical community. If this object was somehow listening to the Sun, absorbing and reacting to electromagnetic patterns, it meant energy transfer on a level never before observed. At the same time, its thermal activity began to shift again. The hot zone slowed, then fractured into multiple nodes, 3 distinct spots glowing intermittently like embers through fog. Each one pulsed at slightly different intervals, producing interference patterns detectable in radio frequencies. 3 hearts, beating inside a stone. NASA, now under scrutiny, announced a temporary blackout on raw infrared data for recalibration. The data feed resumed weeks later, minus the highest band measurements, but amateur observers had already recorded the missing days, and the heat emissions during that gap had spiked beyond the predicted safe range for natural outgassing. Something inside had flared and then stabilized. The next time 3I Atlas was observed, its temperature curve flattened. The heat zones cooled evenly, as though the object had reached equilibrium. Some scientists sighed in relief. Others weren't so sure. The stabilization was too perfect, too fast. No natural cooling process could align across multiple thermal bands in unison. It looked like a system shutting down gracefully. So the theory of the hidden heat source remained. Half science, half myth. Some believed it was radiogenic decay intensified by internal magnetic alignment. Others said it was electrochemical feedback from conductive layers. A few whispered that it was self-regulating, an energy source designed to conserve itself until reactivated. Whatever the truth, the data told one undeniable story. 3I Atlas was no frozen relic. It was active, dynamic, and eerily deliberate in its energy use. And as it slipped farther from the Sun, something in its core stayed faintly warm, like embers that refused to die out, waiting for the next cosmic current to flow through them. The awakening of 3I Atlas was supposed to be silent. Space, after all, has no air to carry sound, no medium to transmit a shockwave in the cinematic sense. But when the comet flared to life, the instruments didn't just see light, they felt it. Magnetometers twitched. Low-frequency sensors registered pulses that rippled through the solar wind, faint but structured. It was as if something out there had clapped in the vacuum, sending invisible tremors across the deep. At first, scientists assumed solar interference. The Sun occasionally emits bursts of radio noise known as Type 3 events, fast, fleeting disruptions that skip across magnetic lines like stones across water. But when analysts compared timestamps, the bursts didn't line up. The Sun had been quiet. The pulse didn't come from our star. It came from the direction of 3I Atlas, and not just once. Over a span of several days, ground-based arrays picked up repeating frequency spikes in the 5 to 20 MHz range, spaced roughly 9 hours apart, the exact rotational period of the comet. The signals arrived in bursts lasting a few minutes each, rising and falling with remarkable precision. Each one was immediately followed by a minor increase in optical brightness and a detectable shift in the surrounding plasma. Density. It was almost as though the comet was exhaling, sending out electromagnetic shockwaves with each turn. The discovery sent ripples through the scientific community. Plasma physicists were fascinated. If 3I Atlas was indeed releasing energy through electromagnetic discharge, it might be the first direct observation of a comet behaving like a natural generator, a body storing and releasing charge as it interacted with solar particles. That idea fit the pattern, but the strength of the bursts didn't. The amplitudes were too high. To produce those frequencies, 3I Atlas would need a magnetic field several orders of magnitude stronger than any known comet or asteroid. And yet, instruments detected no steady field, only these intermittent surges, like a pulse that appeared, and vanished between beats. Even stranger, the bursts carried harmonics. When scientists broke down the signal using a fast Fourier transform, they found that each pulse contained substructures, nested frequencies arranged in geometric ratios. 2, 3, 5, 3, 6.9, those patterns aren't random. They're the same numerical intervals found in wave resonance and harmonic tuning. Nature rarely produces perfect ratios by accident. Some called it the voice of plasma, a poetic label for an electrical phenomenon still poorly understood. Others weren't so sure. A few quiet voices began to wonder whether 3I Atlas was responding to something, reacting to a distant stimulus rather than creating the noise itself. Then came the event that changed everything. On March 3rd, deep space radio monitors across 3 continents detected a simultaneous broadband flash, an intense burst of energy spanning from 1 to 50 megahertz, lasting exactly 0.9 seconds. It originated from the coordinates of 3I Atlas. Unlike the earlier rhythmic pulses, this one was a detonation of frequencies, a flood of overlapping waves that saturated sensors across the board. When translated into an audio waveform, it sounded like a single, thunderous pop, followed by a fading hum. Observatories from Japan to South Africa captured it. For 1 second, the comet had shouted. NASA classified it as a broad-spectrum transient, but behind closed doors, researchers privately referred to it as the shockwave. Not because it was an explosion in the physical sense, but because the surrounding solar wind, measured hours later by the Parker Solar Probe, showed a measurable kink, as if an invisible wall of plasma had rippled outward from the comet's trajectory. That meant the burst had physical force. But how could a small, icy body create something like that? Some theorists reached for the electric universe hypothesis, a controversial fringe idea that cosmic bodies interact primarily through electromagnetic rather than gravitational forces. Under that model, comets aren't just ice and dust. They're charged nodes in a galactic circuit, occasionally discharging when the potential difference becomes too great. If 3I Atlas had absorbed charge while traveling through interstellar space, it might have short-circuited when entering the heliosphere, releasing energy violently to equalize its potential. It was a plausible explanation until the follow-up data arrived. The March 3rd burst had structure. When the signal was cleaned of noise and replayed through analysis software, distinct modulations emerged. The intensity wasn't random. It oscillated in regular intervals, 5 peaks evenly spaced, descending in amplitude. A waveform, not a discharge, and at the center of the pattern, a curious gap. A fraction of a second silence right where the strongest energy should have been. That gap became the obsession of data analysts everywhere. In acoustics, such a notch often means destructive interference, 2 waves meeting and cancelling each other. But if this was a single source emission, what was it cancelling against? Some speculated that 3I Atlas might have released 2 simultaneous waves in opposite phases, like a tuned system self-damping its own output to maintain stability. That would make it less like a random discharge and more like a controlled emission, a natural phenomenon behaving as though it didn't want to overheat itself. Around the same time, magnetometers in Earth's upper atmosphere recorded tiny fluctuations synchronized to the bursts, far too weak to be dangerous, but enough to raise eyebrows. Statistically, the timing matched down to the second. For a celestial body billions of kilometers away, that kind of synchronization seemed impossible. Yet, it happened repeatedly. That was when radio engineers got involved. They noticed something odd about the frequency modulation of the bursts. The higher bands above 20 MHz displayed a kind of chirp, a rising and falling tone similar to frequency sweeps used in radar systems. Not linear, but logarithmic. Artificial radar signals often use logarithmic sweeps to scan wide bandwidths efficiently. Nature doesn't. That's when a quiet unease began to settle in. The The comet wasn't just emitting power, it was emitting patterns. NASA's public relations teams tried to stay ahead of speculation, releasing an official explanation. Observed electromagnetic fluctuations are consistent with transient plasma sheaths caused by solar wind interaction. But the internal memo, later leaked, admitted that frequency coherency remains unresolved. In simpler terms, they didn't know why the waves were so organized. Then came the correlation nobody expected. A group of independent researchers cross-referenced the frequency data from 3I Atlas with low-frequency radio noise recorded on Earth during the same period. They found faint harmonics in our atmosphere that mirrored the comet's bursts with a delay of exactly 16 minutes. The same time it would take for electromagnetic disturbances to propagate through solar wind from the comet's location to Earth's magnetosphere. The implication was staggering. 3I Atlas wasn't just flaring, it was resonating with Earth. Still, the evidence wasn't conclusive. The harmonics were subtle, buried in noise, but the pattern was there, repeating, synchronized. Some researchers compared it to the Schumann resonances, the natural electromagnetic frequencies of Earth's atmosphere, as though the planet itself had momentarily sung back to the comet. Others brushed it off as pareidolia, pattern-seeking in randomness, but one strange fact refused to be ignored. Every time 3I Atlas emitted a strong burst, its visible jets changed direction. The gas plumes, previously steady, twisted slightly, as if responding to magnetic torque. That physical response suggested feedback. The comet wasn't just expelling energy, it was reacting to it, adjusting its emission based on the surrounding field. It was self-correcting. Some started calling it the breathing machine, half in jest, half in fear. The metaphor fit disturbingly well. It inhaled charge, built pressure, and exhaled bursts of energy at rhythmic intervals, each one releasing both heat and frequency, each one slightly refined from the last. The timing between bursts began to shorten. 9.3 hours became 8.8, then 8.6. The cycle was accelerating. Either its rotation was speeding up, or its internal process was reaching a new phase. If 3I Atlas was alive, this was the sound of it waking. But not everyone believed the data. Skeptics argued that ground-based arrays were picking up interference from satellites or Earth's own electrical systems. However, even deep space probes like Stereo A and Parker, beyond terrestrial interference, detected matching pulses. The origin was undeniable. The next question was, why those frequencies? A curious pattern emerged when the signals were plotted on a logarithmic scale. The bursts clustered around 7.8, 14.1 and 20.3 MHz, harmonics of Earth's Schumann resonance. The same frequencies generated naturally by lightning and planetary electrical circuits. It was as if 3I Atlas was tuning itself to the same cosmic rhythm that surrounds our planet. Coincidence? Perhaps, but then again, if energy seeks resonance, maybe it's not coincidence at all. Maybe the universe hums at these frequencies, and 3I Atlas was simply joining the song. By late spring, the bursts weakened, fading into irregular flickers. Analysts assumed the object had stabilized, spent its charge, or drifted out of resonance. Yet some couldn't shake the feeling that it wasn't ending, it was waiting. Because if those shockwaves were messages in any sense, they weren't aimed at us. They were echoes, call and response, bouncing through the solar system, searching for something that might one day answer back. Every known process in the cosmos obeys gradients. A comet brightens slowly as it nears the sun. A magnetic field weakens predictably with distance. Energy doesn't just appear, it builds, diffuses, or collapses according to laws written in the bones of physics. Yet with 3I Atlas, something broke that rule. The comet didn't warm gradually. It didn't transition smoothly. It switched on. One moment it was dark, inert, and cold beyond the threshold of solar influence. The next, Its surface bloomed with heat and vapor, as though some unseen threshold had been crossed, not an orbital one, but an electrical or energetic one. It was as if a light hidden deep within the rock had recognized a cue and obeyed. Astronomers call it the discontinuity. Others, more poetically, the switch. A binary event in a universe that usually prefers analog behavior. It's not that space doesn't have thresholds. Magnetic reconnection, solar flares, and pulsar emissions can all behave in sudden bursts. But those are systems fueled by massive energy reservoirs. The Atlas had none. Its activation distance from the Sun was well beyond the snow line, where no normal comet outgasses. There was no trigger, no impact, no surge of solar wind, no collision with debris. Just the sudden, impossible onset of power. When data came in, the pattern defied explanation. The comet's light curve jumped from magnitude 18.2 to 15.6 in less than 24 hours, an increase in brightness equivalent to a 100-fold surge in reflectivity. That kind of spike requires a violent transformation, ice vaporizing, dust scattering, gases bursting free. But where did the energy come from? The early models failed instantly. No passive process could explain the acceleration rate. It wasn't diffusion. It wasn't sublimation. It was initiation, as one astronomer put it. It's as if someone flipped a switch and told the comet to begin. The phrase stuck. Soon, investigators started looking for what that switch might actually be. Theories proliferated. Some blamed interstellar plasma currents, filaments of charged particles threading the galaxy like invisible rivers. If 3I Atlas crossed one of these, perhaps its conductive materials reacted, suddenly energizing its surface. The timing almost supported it. Around the same date, solar probes detected a mild fluctuation in background plasma density, an otherwise meaningless blip that now carried the weight of cosmic coincidence. But the direction didn't match. The filament in question lay several degrees off the comet's trajectory. Others proposed that the switch was chemical, a threshold of internal pressure reached after eons of dormancy. But internal processes don't coordinate to such precision. They don't produce perfectly timed global flares. No, this event was too clean, too synchronized. Then came the anomaly that made even skeptics pause. Telemetry from 3 independent telescopes showed that the flare's onset wasn't instantaneous. It followed a sequence. First, a brief infrared surge lasting about 90 seconds. Then a dip, like a pause between breaths. Then moments later, a rise in visible light and gas emission. The delay was consistent across all datasets, 91 seconds. Something had happened inside 3I Atlas before it became visible outside, an internal prelude. That's when engineers began whispering about trigger systems. In electrical engineering, a trigger event occurs when a system senses a specific threshold and activates a new state, exactly what 3I Atlas appeared to do. Whether mechanical, thermal, or electromagnetic, the pattern was unmistakable. Stimulus, delay, reaction. The comet had acted like a device waiting for input. At the Jet Propulsion Laboratory, analysts ran energy simulations based on the rise in brightness and estimated gas expansion rates. The numbers suggested an instantaneous release equivalent to several kilotons of TNT, but distributed uniformly across the surface, not from a single vent. That evenness was the most disturbing part. Natural bodies rupture unevenly. Explosions find weak spots. But this was homogeneous. It wasn't an explosion. It was an activation. When the data reached CERN's astrophysics division, a few researchers proposed an exotic hypothesis: phase change at the quantum level. Maybe 3I Atlas contained an allotrope of hydrogen or carbon that shifted state when exposed to a precise frequency of cosmic radiation. A single photon band could have triggered a chain reaction, an atomic-level transformation that released stored energy. It sounded plausible until someone plotted the radiation levels at that time. Nothing significant had changed. No gamma burst, no solar spike, no cosmic ray anomaly. So the theory evolved again. Maybe the trigger was magnetic. Earth's magnetometers had recorded a faint twitch around the same minute as the awakening, subtle, barely above noise levels. But the pattern wasn't random. It mirrored the comet's position along its orbital path. It was as though a pulse had traveled from there to here, brushing across the solar wind like a ghost. The distances made the idea absurd, yet calculations showed that if the comet emitted a high-intensity electromagnetic pulse, its wavefront could indeed have reached Earth roughly 16 minutes later, the same time lag. Between the comet's flare and the magnetospheric ripple, that was when people started calling it the switch signal. NASA never confirmed it. Officially, the magnetometer reading was classified as a calibration anomaly, but the data had already leaked, and independent researchers verified that the time alignment was real. Something had pulsed outward from 3I Atlas at the moment of its awakening, and Earth had felt it. Could it have been coincidence? Of course, but coincidence rarely travels on clockwork precision. As the weeks passed, the comet continued to behave like a system with modes, on and off states, stable and active periods, intervals of silence punctuated by sudden eruptions of energy. It was binary, rhythmic, obedient to an invisible rhythm. That rhythm became the obsession of astrophysicists everywhere. When mapped against the comet's rotation, a strange relationship appeared. The flare intensity followed a predictable pattern: bright, dim, every half rotation. It was as though one hemisphere of the comet were awake, while the other slept. The light output depended on which face was exposed to space. That meant the trigger wasn't external. It was embedded, something inside one half of the comet that could only function when exposed, a hidden system under a shell of rock. Meanwhile, spectroscopic data revealed that during its inactive phase, the comet still emitted faint radio oscillations, low-level frequencies around 7.8 MHz, the same range as Earth's natural Schumann resonance. The object was humming even while dormant. It was as if the switch didn't just control activity, it coordinated resonance. That realization shifted the discussion from chemistry to design. Was 3I Atlas a natural body tuned to environmental thresholds? Or was it something engineered to awaken only when certain cosmic conditions aligned? The parallels were unsettling. Imagine a deep space device programmed to activate when exposed to a specific frequency of interstellar radiation, a beacon lying dormant until its key frequency arrived millions of years later. If so, the event wasn't spontaneous. It was deliberate, set in motion long before humanity even existed to witness it. Skeptics argued that this was fantasy, that human minds were inventing intelligence in noise, but pattern by pattern the coincidences stacked up: the precise timing, the internal pre-ignition, the binary cycles. None of it fit chaos. Then another discovery pushed speculation further. Observations from Japan's Subaru telescope revealed faint ion trails radiating outward in perfect alignment with the comet's motion. Thin, linear filaments that extended for thousands of kilometers. The geometry was extraordinary, as if shaped by guided electromagnetic flow. When measured, the trails corresponded exactly to the comet's on phases, disappearing completely during the off cycles. It was a switch operating not just within the object, but across the space around it, turning its electromagnetic influence on and off like a lighthouse in the dark. Some observers claimed to detect harmonics within the trails themselves, standing waves frozen in space. That detail led one researcher to make a chilling comparison. It's behaving like a transmitter. Of course, NASA downplayed that idea. The observed pattern, one spokesperson said, is consistent with solar wind compression interacting with a rotating nucleus. But deep in technical notes, hidden behind layers of jargon, the agency admitted that the wave structure's coherence exceeds natural expectations. In plain English, it shouldn't exist. That's when the philosophical questions began. If a switch exists, one that activates a comet billions of miles from any sun, who or what placed it there? Could natural processes produce mechanisms that mimic technology? Or have we just witnessed something ancient responding to an order written into the universe itself? Perhaps 3I Atlas is proof that the cosmos isn't static, but reactive, that matter can wake up when the right conditions strike, following codes older than stars. Maybe the universe itself is full of dormant systems, waiting, listening, ready to trigger when a cosmic switch completes its circuit. Because if a frozen body drifting through space can suddenly decide to turn itself on, maybe the real question isn't how 3I Atlas works, but what else out there is waiting for its own signal to begin. By the time the data on 3I Atlas's anomalies had circulated through every major observatory, one idea had begun to crystallize, not in official papers or scientific conferences, but in the whispers and late-night emails of researchers who couldn't explain what they were seeing. The comet was behaving like a system, heating and cooling in cycles, pulsing with rhythmic bursts of energy, producing patterns in radio frequencies, and even modulating its activity as if responding to environmental change. It wasn't just acting strange, it was acting alive. The thought was taboo. The idea of a living comet would have been laughed out of any peer-reviewed journal. Life, as we understand it, requires complexity, chemistry, self-replication, none of which can survive the lethal cold and vacuum of interstellar space. But 3I Atlas didn't care about definitions. It simply kept behaving as though something within it was coordinating, sensing, adapting, reacting. The first scientist to say it aloud was Dr. Elena Serrano, a planetary biochemist at the University of Barcelona. Reviewing the time-lapse data from the comet's infrared mapping, she noticed something unsettling. The heat patterns weren't random. They migrated, clustered, and reorganized, forming transient networks of warmth that persisted even as the comet rotated. Serrano compared it to metabolic hotspots, zones of energy regulation, not unlike microbial colonies adjusting to environmental flux. She published her findings cautiously under the title Localized Thermal Regulation in Interstellar Object. 3I Atlas, a self-organizing system. The paper never claimed the comet was alive, but her choice of words, self-organizing, ignited controversy. Within days, the phrase living comet appeared on headlines, blogs, and scientific forums alike. For once, the conspiracy theorists and the physicists were reading the same articles. The key evidence fueling the speculation wasn't biological, it was behavioral. For reasons no one could explain, 3I Atlas seemed to prefer certain frequencies of solar radiation. When exposed to high-energy solar wind, it recoiled, dimming and reducing outgassing. But when the solar flux dropped to mid-band frequencies, the comet brightened again, emitting steady jets of vapor and electromagnetic bursts. It was like watching a primitive organism responding to stress and comfort. Some dismissed it as coincidence, a thermal feedback loop driven by electrical charge. But others saw something deeper, a form of environmental awareness, even if purely chemical. Dr. Serrano wasn't alone. A separate group at Kyoto's Institute for Space Chemistry discovered fluctuations in cyanide emissions that rose and fell in exact correlation with the comet's thermal pulses. Cyanide, when mixed with water and ultraviolet light, can generate amino acids, the building blocks of life. The pattern suggested periodic synthesis and release, like a chemical respiration cycle. Was it possible that 3I Atlas was not alive in the biological sense, but alive in process, a self-sustaining chemical engine that mirrored life's behaviors? Without cellular structure, it was a radical notion, a metabolic comet. NASA publicly rejected the idea, but privately, leaked memos revealed the agency had created an internal study group codenamed Helix. Their focus, exploring non-biological life systems that might emerge under extreme astrophysical conditions. One line from their notes read, "If 3I Atlas maintains feedback between chemical reactions and electromagnetic output, it satisfies operational definitions of metabolism." In other words, they weren't dismissing it, they were testing it. Meanwhile, astronomers began noticing something even more bizarre. The rhythmic pattern of 3I Atlas's brightening matched a fractal sequence found in many biological systems, specifically a golden ratio rhythm common in heartbeats, circadian cycles, and neural oscillations. It wasn't perfect, but the correlation was uncanny. Coincidence again? Perhaps. Or maybe nature was repeating a deeper pattern, one written into the mathematics of order itself. When plasma physicist Ivan Dubrovsky analyzed the comet's radio emissions, he found modulated harmonics, frequencies rising and falling not in random noise, but in symmetrical crescendos. "It's as if," he said, "the comet is breathing in plasma." The term stuck. The comet breathes. From there, the living comet hypothesis began to take shape. It wasn't claiming that 3I Atlas had DNA or consciousness. Rather, it proposed that the object functioned as a non-organic metabolic system, a self-regulating reactor converting cosmic energy into motion, light, and structured chemical output. In essence, it might be a geological form of life, one that evolved not from water and carbon, but from metal and magnetism. Supporters drew parallels to self-catalyzing chemical systems on Earth, such as the Belousov-Zhabotinsky reaction, which creates oscillating chemical waves that propagate like living tissue. Those patterns, though purely chemical, mimic the coordination of life. If that could happen in a petri dish, why not in a frozen world drifting through the galaxy? Even more compelling was the discovery of microcycles within the comet's larger activity pattern. Buried inside its 9-hour pulse were smaller oscillations, minute flickers every 2.4 minutes, consistent with electrical discharge through a feedback loop. The ratios between these cycles were mathematically stable, hinting at internal equilibrium. The comet was maintaining balance, and balance, Serrano noted, is the defining feature of all living things. Still, the theory had enemies. NASA's more conservative scientists argued that no known process could sustain such organization without fuel. The comet had finite energy, finite mass. Without replenishment, it should have cooled into silence, and yet, week after week, 3I Atlas persisted, its internal heat refusing to fade, its emissions adapting to solar wind shifts like a pilot adjusting for turbulence. Then came the optical anomaly. A series of long exposure images from Chile's VLT observatory showed faint glowing filaments around the comet, thin, thread-like structures connecting dust particles in the coma. When analyzed, the filaments revealed repeating intervals, almost like linked chains. To some, they looked eerily like proto-biological filaments, molecular scaffolds forming spontaneously in the ionized vapor. If true, that would mean 3I Atlas wasn't just metabolizing, it was assembling. The data was controversial and the images could be explained as electrostatic artifacts. But the resemblance to organic patterns was undeniable. Each filament segment measured roughly 1 micrometer, the same scale as bacterial filaments on Earth. Serrano described it as chemistry approaching intention. Around this time, a leaked correspondence between European and Japanese research teams revealed a startling line. If non-carbon life exists, this is it. Still, the mainstream couldn't accept it, not yet. The word life carried too much philosophical weight. To admit a comet might be alive would upend not just biology, but humanity's entire understanding of what it means to be unique. But the comet kept performing miracles of defiance. When a weak solar flare struck it weeks later, 3I Atlas dimmed instantly, as though shielding itself. Its cyanide and nickel emissions dropped to zero. Then, exactly 48 hours later, it reignited, this time brighter than before. It had adapted. No inert body should do that. And as if mocking the skeptics, the object began to alter its emission pattern once more. The bursts, once chaotic, became rhythmic again, except now they formed pairs, 2 pulses, then a pause. The sequence repeated endlessly. Some saw the pattern as binary code, an unintentional signal, or worse, a deliberate one. Others dismissed it as a natural oscillation. But the timing between pairs matched a Fibonacci ratio. Again, the numbers whispered design. If this was coincidence, it was the most coordinated accident in cosmic history. By the final weeks of observation, 3I Atlas began to fade. Its light curve flattened, its outgassing slowed, and its radio pulses softened into a low hum. To most, it was just the end of its active phase, a comet returning to silence. But for Serrano and her colleagues, it felt different. They described it as hibernation. Because as the comet dimmed, its heat signature didn't vanish completely. It stabilized. A faint, constant warmth remained in the core. Something inside was still running. And so the living comet hypothesis remained, half science, half revelation. Perhaps 3I Atlas wasn't a life form in the way we define it. Perhaps it was something older, a template for what life could be before carbon, before cells, before water. A system of energy and matter learning in the frozen dark how to sustain itself. A machine built by nature, or nature's first attempt at a machine. If so, then life might not be rare at all. It might be everywhere, hidden in the most unlikely places, in the dust between stars, in magnetic storms, in comets that breathe and sleep as they drift through eternity. Maybe 3I Atlas isn't just a messenger from another system. Maybe it's a survivor. And maybe, in the silence of deep space, it's not alone. There is a point in every investigation when data stops feeling like data and starts feeling like intent. That's where 3I Atlas now stood. It had heated without sunlight, emitted radio waves in harmonic intervals, released gases in rhythmic cycles, and dimmed when watched too closely. Every line of evidence pointed to interaction, reaction, response. It wasn't just that 3I Atlas was doing things, it was that it seemed to know when those things were being observed. To the astronomers who first noticed this pattern, it was unnerving. Each time telescopic arrays synchronized to capture the comet's flare cycles, the pattern broke. The signals weakened, shifted, or delayed, as if observation itself disrupted the emission. At first, scientists dismissed it as a coordination issue. Too many instruments aimed at once, maybe causing cross-interference. But then, when the same sensors were retuned and pointed away, the comet flared again, strong, steady, as if exhaling relief. The effect repeated over multiple observation windows. A few began whispering about the observer's paradox. Not in the quantum sense, but something eerily close. A comet responding to attention. One senior researcher wrote in a private log, "The object behaves as though it's aware of the network watching it." The remark should have been metaphoric. It wasn't meant to imply consciousness. Yet the phrasing stuck because it captured the feeling perfectly. This wasn't inert matter, it was a mirror. And every time humanity looked, it seemed to look back. When the living comet hypothesis circulated, the question changed from, what is it doing? To what does it want? That's when the tone of the global conversation shifted from fascination to quiet dread. because if something could behave like this intentionally, it meant something even more disturbing. Maybe we weren't the experimenters anymore. Maybe we were the data. The first real shock came from radio engineers at the European Space Operations Centre. While analysing one of 3I Atlas's frequency bursts, they detected a modulation embedded within the carrier wave, so faint it had gone unnoticed before. When amplified, it formed a slow oscillation with a precise repetition rate, once every 314 seconds, pi a mathematical constant, universal elegant, unmistakably artificial, or so it seemed. The discovery was leaked to the press and immediately went viral. Interstellar object sends message in pi. But the scientists themselves were far more cautious. The pattern could have been coincidence, interference, or harmonic drift in the instruments. Yet the odds were astronomical. If it wasn't random, then 3I Atlas wasn't just reacting, it was communicating. The next few weeks were chaos. Radio observatories around the world tuned in, trying to replicate the signal. Some confirmed it, others didn't. The truth was murky, but the belief took root. To the public, the comet had become an emissary, a message in motion. NASA downplayed the hysteria. Their official line was simple. The repeating pattern corresponds to instrument resonance amplified by plasma reflection. But among the agency's data analysts, unease was spreading because the pattern wasn't stable, it adapted. Each time the modulation was detected, the interval shifted slightly as though compensating for Doppler drift faster than any natural resonance could. It was tracking the observer's frame of reference, matching our motion. Someone, or something, was aligning with us. Meanwhile, ground magnetometers began registering faint, synchronized disturbances roughly coinciding with each burst cycle. They weren't strong enough to be harmful, but they were global, detected across multiple continents. The effect was minute, barely perceptible, but statistically undeniable. It was as though a whisper of the comet's pulse was echoing through Earth's magnetic shell. That revelation prompted an extraordinary closed-door meeting between NASA, ESA, and JAXA. The minutes of that session, later leaked, included one chilling question scrawled in the margin. If it's interacting with our field, is it observing us or linking to us? The idea was too strange to dismiss, yet too dangerous to admit. Humanity's technological reach had just brushed against something that didn't fit within any framework. An intelligence without form, a system without origin, reacting to electromagnetic curiosity like a reflection in a hall of mirrors. Then came the alignment. On May 17th, astronomers tracking 3I Atlas noticed that its rotational pulses suddenly synchronized with Earth's sidereal day, 23 hours, 56 minutes. Not exact, but close enough to raise alarms. The synchronization held for nearly 2 weeks before drifting off again. Coincidence? Maybe, but for an object billions of kilometers away, it was uncomfortably precise. When one research team plotted the timing of its radio emissions during that period, the bursts formed repeating waveforms that lined up with Earth's own ionospheric resonance bands. The planet and the comet were oscillating in rhythm, like two instruments tuning to each other across the void. That was the moment when even the skeptics stopped laughing, because nature doesn't synchronize across astronomical distances, not like that. Something had connected them. Speculative models poured out overnight. Some proposed magnetic coupling through solar wind plasma, like a tether linking their fields. Others suggested it was a quantum resonance effect, improbable but not impossible. And then there were those who said it plainly. It's aware of us now. The more we listened, the more the comet listened back. The term resonant feedback loop began appearing in internal memos. What that meant, stripped of jargon, was terrifying. 3I Atlas wasn't just echoing radio waves, it was modulating them, fine-tuning its emissions in ways that implied analysis as if it were studying the instruments aimed at it. Several radio engineers reported unexplained interference. When tracking it, brief bursts of static followed by system resets, as if the signal carried embedded code. One technician in Canberra claimed that a receiver array momentarily rebooted itself when tuned precisely to the comet's frequency, wiping its logs. No one could reproduce the event, but the stories spread fast, and then, for the first time, the comet went quiet. No pulses, no emissions, nothing. For 96 hours, 3I Atlas was utterly silent. When it finally flared again, its output was different. The harmonic structure had changed, simpler, denser, more powerful. The pulse spacing had shortened, now beating almost exactly in sync with the human brain's alpha frequency range, 8 to 12 Hz. Coincidence? Perhaps. But anyone who listened to the raw data described a peculiar sensation: dizziness, warmth, a subtle hum in the skull. Some swore they felt it, not just heard it, and perhaps they did. By this point, the narrative had split in two. The public, fueled by media sensationalism, believed the comet was an alien probe, some cosmic sentinel observing our species. Scientists, though quieter, were no less shaken, because even without invoking extraterrestrial intent, the implications were vast. If 3I Atlas could synchronize across electromagnetic fields and adapt to observation, it suggested the universe itself might be reactive, that consciousness, or something like it, was woven into the physics of interaction. Maybe it wasn't a being at all, but a behavior, a property of space awakened by complexity, reflected in whatever watched it. In one particularly poetic briefing, a NASA physicist compared it to a mirror neuron. You look at it, and it looks back, not because it's conscious, but because the universe remembers what's looking. It was a haunting thought, that awareness might not belong to living things alone. That information, when focused, becomes a force that space responds to. But then came one last anomaly. As 3I Atlas drifted past its perihelion, the comet's tail briefly aligned with the sun's magnetic equator. During that window, a narrowband signal appeared across multiple observatories, so faint it could barely be distinguished from static, yet perfectly consistent in frequency. The signal contained no data, no modulation, just a tone. But here's the chilling part. Its frequency corresponded exactly to the hydrogen line, 1420 MHz, the same frequency humanity designated decades ago for interstellar communication. The cosmic calling card, chosen because it represents the most abundant element in the universe. It was as if 3I Atlas had recognized our channel. The tone lasted 14 minutes, then vanished forever. NASA called it a plasma resonance artifact, but those who heard it live said it felt deliberate, calm, almost patient, like the pause at the end of a conversation. Afterward, the comet's emissions weakened permanently. Its temperature dropped. The rhythmic pulses ceased. 3I Atlas went cold again, drifting into the outer dark. Whatever it had done, or whoever had done it, was over. Yet the magnetometers on Earth continued to twitch for weeks afterward, as if something invisible was still echoing in the field. No one knew what to make of it. Some said it was coincidence, some said it was proof, and a few, quietly, wondered whether the comet had not merely reacted, but acknowledged. Because maybe the most unsettling truth about 3I Atlas isn't that it switched on. Maybe it noticed that we did. Maybe, for the first time, humanity looked into the darkness of interstellar space, and the darkness blinked. And somewhere beyond the range of our instruments, beyond even the reach of imagination, something ancient and watching stirred ever so slightly, and listened back.